Hi, Andy from Sony again, and in this video I thought I'd take a few minutes to tell you about some of our microphone technology. As I've mentioned before, we have a long history in making microphones. Our first microphones had to support our very first product as a company back in 1950, a reel-to-reel tape recorder, and we built our first microphone. But we have continued to make incredible microphones and legendary microphones in many cases through the years. As a matter of fact, Frank Sinatra came to love our C37 microphone way back when. And we've continued to improve technologies for our microphones through the years. So, since microphones are absolutely so critical to the work that you all do in location sound, I thought you'd at least be interested in hearing about some of our technology, some that apply directly to what you do, and some that I hope you just find interesting. So the first thing, I did want to describe our latest lavalier microphone, as it is very close to the world you live in. It is the world you live in, lavalier microphones. And certainly we all have our favorites and industry standards and things like that. But I wanted you to know about a very unique new lavalier that we've introduced at Sony. It's called an ECM90. And an ECM90 is special because in the world of lavaliers, even though lav manufacturers don't like to talk about it, and you all have to struggle with the issue every time you kind of mount a lavalier on talent or wire up talent, there is cable noise, and you've got to try to find ways of isolating the microphone from the cable as you dress it under talent's clothing so you don't get rubbing noise and things like that. And through the years, various manufacturers have tried different pliability of cables and different coatings and things like that with a bit of success, let's put it that way. But don't ever tell a Sony engineer that he can't solve a problem. They absolutely hate that. So our Sony engineers got to work on this issue in particular and said, you know, one of the things that people are asking for is even smaller and smaller lavaliers. They want these things to be so tiny these days, barely larger than the cables themselves. And they also realize that it's very common that most lavaliers use a round diaphragm in the tip of a round capsule. And if you think that if you make the capsule as small as people want it to be, so then the diaphragm has to get very, very tiny as well. And when you make a round diaphragm that small, you lose frequency response, you lose dynamic range, and the inherent noise goes up. Well, our Sony engineers didn't want to suffer those trade-offs. And they said, well, let's think about this a little bit differently. Who says that we have to use a round diaphragm and the round tip of the capsule? What if we try a different approach? What if we take a large rectangular diaphragm and lay it down the side of the capsule? Now the diaphragm can be so large that it can have a full 20 to 20K frequency response, and it can have very, very low noise and great dynamic range. And while we're at it, let's put one on the other side of the capsule as well. So now we've got double diaphragms for a huge amount of diaphragm space. But the magic happened because there is so much room now down the side of the capsule that we could build really excellent isolation mounting of that diaphragm. If you realize that because you have trade-offs in, you know, having a smaller round diaphragm in the tip of a capsule, if you've got to keep that diaphragm as large as you might want to, you know, not lose so much frequency response and noise, you keep it so large, but then you don't really have any room to do an adequate job of isolating it from the capsule body or from the cable. Well, in our approach, we have lots of room, so we designed a really excellent diaphragm mounting tray that isolates it beautifully and also adds kind of water resistance or perspiration resistance as well. And what we have been able to do is reduce that amount of cable noise that we're so used to fighting against by, I would say, 90 to 95%. I'm wearing two lavs right now, and one of them is an ECM77, which we've had in the line for many, many years. And this is the traditional amount of cable noise that you would get out of this microphone, as well as, I bet, just about most of the lavs that you use currently in the market. This, on the other hand, is our ECM90. Hi, bird. And here we have cut down the amount of noise dramatically, right? I hope you can hear that. Now, as well, this ECM90 is properly shielded for use with digital transmitters. It can certainly be used with analog transmitters, but digital transmitters need a proper shielding so that the digital transmission noise doesn't get up into the condenser capsules. So that's our ECM90, very, very small, sounds great, and hope you'll get a chance to play with it. Our many location sound dealers in the US all have these microphones, and I hope you will call them up and see if you can play with it, get a demo for it. Now, going maybe a little bit back a year or two, we've introduced a new series of high-end studio microphones, but not just for studio applications, quite honestly. But we are saying that these microphones, we are calling them high-resolution microphones because they have an exceptionally wide frequency response that goes from 20 hertz all the way out to 50K. And that's quite something. Now, you can say, oh, I don't hear out that high. But this microphone is so incredibly fast, and it doesn't start rolling off until way, way high up in the frequency range. If you have a mic that says it goes from 20 to 20K, I bet it starts rolling off, kind of it starts approaching those upper frequencies. So you're not really getting the full pop, if you will, out of that microphone. But these mics go all the way out to 50K, and they are very, very fast. In this particular case, in the C100 microphone, it's a dual diaphragm design. There's twin capsules in here, but they're not the same size. One diaphragm is a large diaphragm and covers the frequency range of 20 hertz up to 25K. And then, due to its backplane design, it has a natural roll-off of frequency response, so it doesn't have to go through a crossover network, which could hurt the sound. And then we go to a small diaphragm up above, and that diaphragm, in this case, covers 25K out to 50K. Kind of incredible. And as well, in our pencil microphones, and we offer a kind of a cardioid and an omni microphone, I've had some location sound mixers use our cardioid in boom pole applications and exclaim to me that they have never heard talent sound so incredibly natural, like the way they do in real life. So if you get a chance, I hope you get a chance to play with this microphone. But on the C100, either of these microphones, to tell you the truth, a very interesting thing having to do with the world of sound for cinema is that since these go out so high, you can use them for sound design. You can capture sound effects at high sampling rates and very speed them way down, and they will still have plenty of frequency response and make for a great sound effect. So maybe you got a chance to play with that if that's the business you're in. These are the C100 and the ECM100U for unidirectional or cardioid, and an ECM100N for omni. So finally, one more microphone I wanted to let you know of. You may be well familiar with it, but it is an incredibly popular microphone for us and very sought after in the music world. It's called a C800G. And I'm trying to explain to you how crazy our engineers are, and they're never willing to settle for having a problem with something. And back in 1990, when we first started working on the design of this tube microphone, our engineers said, well, let's go buy all the other tube microphones in the market and listen to them and test them. And what they found out almost immediately is their sound changed on a day-to-day basis, largely to do with the temperature of the studio they were in, for example, because the temperature of the tube has a big impact on the sound of the microphone and the noise floor and all those things. So our engineers tested our prototype C800G microphone and found out that if you kept the tube at exactly 13 degrees Celsius or low 50s Fahrenheit, that would yield the absolute best sounding and lowest noise floor that this microphone was capable of. But it's got a hot glowing tube in it. How are you going to keep that tube from straying from 13 degrees Celsius? Yeah, certainly can't dunk this in a bucket of water to keep it cool, and you can't throw an air conditioner blowing cold air on it. That wouldn't work. So our engineers looked for an alternate solution. And what they came up with was kind of incredible. There was a device they found, a semiconductor device, called a Peltier device, P-E-L-T-I-E-R. It's a unique device where one side of the device heats up, like you'd expect a chip to do, but the other side of it literally gets cold. It cools down. And now those are used more commonly in car refrigerators and cooling computer towers and things like that. But back in 1991, they took the cold side of this Peltier device and they laid it right next to the tube. They even used some thermal kind of grease for conductivity, thermal conductivity. And we could then regulate the temperature of that tube with the cold side of the Peltier device to stay at exactly 13 degrees Celsius and maintain the best spec. But the next thing they did was, I think, even more incredible. You've got to get rid of that heat still. So the unit, the C800G, has a heat sink. But the heat is not going to go from here out to from the tube area out to the heat sink all by itself. And as a matter of fact, there is a hollow pipe that connects the two. It's closed at both ends, but it is filled with a very specially chosen fluid. Why is specially chosen fluid? Because different fluids have different boiling points. And what happens when you boil a fluid? It turns into a gas. So we chose a fluid that would boil literally at the temperature of the hot glowing tube. And if you keep the microphone horizontally mounted or even with the heat sink slightly elevated, what happens is you create hot gas bubbles that then float up out to the end of the pipe and leave their heat out to the heat sinks. And then those gas bubbles cool off and they condense back into a liquid form and they drain back down the bottom half of the pipe and get ready to go for another round trip all day long, keeping the microphone at exactly 13 degrees Celsius. It is, I believe, the world's first thermoelectrically liquid-cooled condenser tube microphone, the C800G. So I hope you found that interesting. It just shows to what lengths Sony engineers will go to solve common problems that exist in many different kinds of products in the industry. If you'd like more information on any of our microphones, including our shotgun microphones and things like that, please go to sony.com/proaudio. And if you'd like to try our new ECM90 lavalier, go to your location sound dealers and ask for a demo. Anyway, thanks very much for spending the time. Hope you enjoyed this little view into this world of Sony microphones, and stay well. Thanks again. Bye-bye.